Jupiter is a giant ball of gas, bigger than all the other planets put together. Jupiter spins like a top. It has the shortest day of any planet, turning once on its axis in less than 10 hours. Glimmering through Jupiter's ring of dust, the Sun is but a beacon 780 million kilometers distant. So remote that it takes Jupiter nearly 12 years to orbit the Sun. Jupiter dwarfs our planet. It needs 11 Earths to span Jupiter's diameter, and over 1,300 to fill its volume. Where comets are concerned, Jupiter is like a vacuum cleaner. This comet, on a journey from the fringes of the solar system, swings a little too close. It's captured by Jupiter's gravity. Subject to forces hundreds of times greater than the pull of the Moon on the ocean tides of Earth, the comet fragments. It's July 1994, and more than 20 pieces of Comet Shoemaker-Levy 9 plunge towards Jupiter. In 1977, from our little blue planet, twin space probes head for the outer solar system. They're the Voyager missions, whose first target is Jupiter. 2 years later, the planet fills their sights. It's like no other. There's no surface, no solid features, just gas, whirling in gigantic belts of weather. The belts blow in opposite directions, eddies and storms racing round the planet. The biggest is the Great Red Spot, a tempest 3 times the size of Earth, an anticyclone that's raged for centuries. At the top, the red spot from Voyager 1, below from Voyager 2. Ten years later, from Earth orbit, Space Shuttle launches Galileo. By way of Venus and twice past Earth, it's 6 long years to Jupiter. Galileo makes it. In 1995, a probe is deployed for a descent into hell. The plunge is slowed by parachute. Every second is vital for research. The clouds thicken. Winds blow at 500 kilometers an hour, driven by Jupiter's heat. Temperatures soar. Jupiter generates far more heat than it receives from the Sun. The core is 30,000 degrees Celsius. 40 minutes in, and the atmosphere is 10 times denser than Earth's. 1 hour in, and the Galileo probe expires, crushed by pressure. Jupiter is 90% hydrogen, the rest mainly helium. Haze tops the atmosphere. Then crystals of ammonia, ammonium hydrosulfide, water ice, and droplets of water and ammonia. Deeper to hydrogen and helium, liquid hydrogen, metallic hydrogen, and a rocky core. It's that liquid metallic hydrogen that generates Jupiter's magnetic field. This donut-shaped zone buzzes with electrified particles. But Jupiter's magnetosphere stretches much farther. After the Sun, it's the biggest entity in the solar system. And where the solar wind funnels toward the planet, auroral halos display around the poles as charged particles interact with the upper atmosphere. The 16 moons of Jupiter. Galileo, after launching its probe into Jupiter's clouds, has business with these satellites. First to Io, a moon flexed by the tug of Jupiter and the pull of a neighboring moon. The result is erupting volcanoes, first pictured by Voyager. Io is the most volcanically active body in the solar system. It heaves with eruptions. Lava relays the surface over and over again. Plumes feed the sulfurous atmosphere. By contrast, this moon is placid, Ganymede. At minus 150 degrees, the icy crust is 100 kilometers thick. Ganymede is the largest moon in the solar system, bigger even than the planet Mercury. Around Ganymede, Galileo detects a weak magnetic field. It hints at the internal structure. Beneath the crust, a mantle of slush. Then a layer of rock and ice surrounding a silicate core. Almost Ganymede's double is this moon, Callisto, except for the craters. They record eons of bombardment. The greatest impact site, a vast ringed basin. And here's another imaged by Galileo. If there's extraterrestrial life in the solar system, it could be here, on Europa. Smooth and cracked like an eggshell, there's a theory that the whole moon is an ice-covered ocean, a possible medium for life. For the waters may be warm, heated by gravitational flexing caused by Ganymede and Io.